In this class, we're going to take a look at how you factorise expressions as a difference of two squares. So a difference of two squares literally means something squared minus something squared. So difference in mathematics means minus, basically, the difference between two numbers. So we're looking for expressions here where you've got something squared minus something squared, and we want to learn how to factorise those guys into, well, in this case, it's going to be into two brackets. So the way this works, basically, is that we consider how the brackets will look, so that if you multiply out the brackets, you would get back to this here. So remember, when you're multiplying out brackets, let me just put an example over here. If you had, say, x plus 2x, say, plus 4, when you're multiplying out those brackets, you do x times x to give you x squared, you get a 2 times x to give you 2x, you get a 2 times, an x times 4 to give you a 4x, and you get a 2 times 4 to give you an 8. You then combine the two middle terms, and you get a 6x plus 8. Okay, but once you've multiplied those brackets out, you basically end up with 3 terms. But notice that this guy here's only got 2 terms. So somehow the format of the brackets has got to allow the fact that when we multiply it out, we don't get 3 terms like a trinomial, but we only get 2 terms. The only way that that can happen is if some of the terms cancel each other out. And we've ended up with a 6x here, which was a combination of these two. But imagine if those two actually just disappeared, like say they cancelled because that one was also a minus 2x. So minus 2x plus 2x would give you 0, so that guy would disappear and you would just end up with 2 terms. So that's effectively what we're looking for in these guys. We're looking for a clever way of factorising so that the middle terms of multiplying out the bracket disappear. To do that, what we do is, well, to make an a squared, you would need an a and you would need an a. To make a b squared, you'll need a b times a b. But then we just think, okay, right, what would happen if we multiplied that out? We would get an a squared, which I'll put there. We would get a b times a b, giving us a b squared. What can I do about the middle terms? Let me just move my b squared over a bit. What can we do about the middle terms? Well, this is going to multiply to give you a ba. This is going to multiply to give you another ba. We want those guys to cancel, just like my 2x and my minus 2x. That means that one would have to be positive, one would have to be negative. Well, for that to be the case, let's say we assign that one as positive, so that's giving you the positive ba, and then assign that one as minus, so minus ba, multiplying these two together, then that would achieve what we want, because these guys would cancel, and the b times the minus b would give us a minus b squared. So tidying that up, we would get a squared minus b squared. So you don't need to know all of that. That's just kind of derivation, I guess. But basically, when you factorise a difference of squares, you just put this number times this number to give you that, this number times this number or letter to give you that, and a plus and a minus. So these guys have to be the same, these guys have to be the same, and these guys have to be a plus and a minus. Doesn't matter the order, it could be plus minus or minus plus, but that is always the format you're looking for in a difference of squares. Another way you could think about it is that the number that goes here and here, or the letter that goes here and here, is going to be the square root of this. But usually we can just look at it and tell what it's going to be. It's normally quite straightforward. One of the challenges, though, in this topic, probably the main challenge, is not knowing what to do with the factorising, because it's one of the easier forms of factorising, because the format never really changes, 2 brackets, a plus, a minus, and pulling in the numbers. It's more recognising when you've got a difference of squares in the first place. This is literally a difference of squares, something squared minus something squared. These guys might not be, in fact, they're definitely not obviously differences of squares. So sometimes you've got to manipulate them a little or recognise them as differences of squares. So this guy here, yeah, the a squared, that's fine, that's something squared. This is not something squared, but 16 is 4 squared. So we can just manipulate that into a difference of squares. Now it's in the correct format, we can just go ahead and say, right, cool, we'll put down our 2 brackets. We're going to put an a there and an a there to give us the a squared. We're going to put a 4 here and a 4 here to give us a 4 squared, or 16, because you don't need this line of working. So you can think of this as either 4 squared from that line or 16 from this line. It's always a plus and a minus. It doesn't matter on the order. That's us done. That's the kind of thought process you'll need to go through. Usually you'll just go straight from that line to that line, because you know that it has to be the square root of that number that goes in your bracket. This one, x squared minus 1, this is kind of a special case in a way, because 1 doesn't appear to have a square root. Well, it's certainly not a number squared, but 1 is 1 squared. So that is actually already in the format of a squared, just in a secret format. So we can actually just go straight with this one to x. We're going to need a 1 and a 1 to make the 1 or the 1 squared, and we'll need a minus and a plus, or a plus and a minus, doesn't matter on the signs. That one's a good one to remember. That comes up quite a lot actually, x squared minus 1. So try and almost remember that one as a special case. It's very easy to forget that the 1 can be made from a 1 times a 1. Okay, the last guy is not looking good at all. It doesn't look anything like a difference of squares. It's got a squared in it, but the format's quite different. So what's going on with this one is we need to do a little factorising before we consider the difference of squares. And you can see that there's a common factor here of 3. So thinking of just common factor factorising first, we pull out the common factor of 3, and then we've got a difference of squares inside the bracket. So this is a very common scenario actually. So it's good for you to practice some of these and to see a few of these, because we've not even done the difference of squares yet. Without doing that first factorisation, we would never even realise that there's a difference of squares there. So we keep the 3. We can see that that's x squared minus 2 squared. So we just go x minus 2, x plus 2, or the other way around, x plus 2, x minus 2, doesn't matter. And that's that guy fully factorised. Common mistake here is to then drop the 3 on the second line, but you need to keep the 3, because if you multiply that out, that should take you back to that first line of working. So that's how you factorise a difference of squares. Not a particularly difficult technique, but it's definitely one of those which is often forgotten about, and which is difficult sometimes in the middle of a long, complicated question to recognise that you've got a difference of squares. A lot of questions will require you to work through, a bunch of working, and then you get to a point where you need to factorise. If it's a trinomial or a common factor type factorising, they're usually quite recognisable. Students tend to forget about a difference of squares, but keep an eye out for that, because they are fairly popular. And if you cannot get that factorising right, then it's going to throw off the rest of the question. So generally, these are not a question in and of themselves. They could be if you were working this as a new topic, but once you've got enough skill with them and you've practiced them enough, you're going to start to see them in other question types. So it's worth spending some time on this, because it is a core algebra skill like all the other factorising. So common factor, trinomial factorising, and differences of squares. And with all these core algebra skills, you just want to get to a level where you don't really think about it. You just see them and you're like, yeah, that's a difference of squares. I'm just going to write down the answer. So check out some practice questions on factorising as a difference of squares.